Hi dear students, this is ARITRAS CHAKRABORTY. Today I am going to discuss about the different characteristics of DC motor. So at first we have to know what are the different characteristics of DC motor. So generally three characteristics curve are considered important for DC motor, which are torque versus armature current, speed versus armature current, and the last one is the mechanical characteristics or speed versus torque characteristics. So these are explained below for each type of DC motor. That means for series motor, for shunt motor, and as well as for the compound motors. These characteristics are determined by keeping the following two relation. Number one, this is the torque equation, that is TA stands for the armature torque proportional to phi into Ia. Phi is the magnetic flux in the DC motor and Ia is the armature current. And another one is N proportional to EB by phi. N is the speed of DC motor in RPM. EB is the back EMF, that is equals to V minus Ia into Ra by phi is the magnetic flux. So these above equations can be studied at EMF and torque equation of DC machines for a DC motor. So magnitude of the back EMF is given by the same EMF equation of DC generator, or you can say that EB and EG, EB is for DC motor and EG is for DC generator, both are same. So that is why we can write down that EB equals to P phi NZ by 60 into A. P is the number of pole, phi is the flux per pole, N is the speed in RPM, Z is the number of conductor by 60 into A. A means the number of parallel path. For a machine, P, Z, A are constant. Therefore, we can write down that N proportional to EB by phi. So now we are going to discuss the first, that is the torque versus armature current characteristics of DC series motor. Here you can see the graphical representation of torque versus armature current characteristics of DC series motor. Okay. So this characteristics is also known as electrical characteristics. We know that the torque is directly proportional to the product of armature current and field flux, that is T proportional to phi Ia. And in case of DC motor, the field winding is connected in series with the armature. So that means the Ia is the IF or field current. So therefore, before magnetic saturation of the field, flux phi is directly proportional to the Ia, or we can say that Ia proportional to phi. Hence, before magnetic saturation, so TA proportional to Ia square. Therefore, TA versus Ia curve is a parabola for smaller value of Ia. That means after magnetic saturation, the field poles flux phi is independent of armature current Ia. Therefore, the torque varies proportionally to Ia only. So T proportional to Ia after the saturation. Therefore, after magnetic saturation, TA Ia curve becomes a straight line. But before that, it is a parabolic in nature. That means TA proportional to Ia square. So torque increased in square by the increasing of the armature current. And the shaft the TSH, the shaft torque, is less than the armature torque due to stray losses. Hence, the curve TSH versus IA lies slightly lower because due to stray loss, the torque of armature is greater than the torque of the shaft. And in DC series motor, the torque increases as the square of armature current. This motor are usually with high starting torque. That means this type of motor is used where the high starting torque is required. And for that very reason, this type of motors are mainly used in case of electric traction or electric tram, metro rail. In that very operation, the DC series motor is used. Now the next one is the speed versus armature current curve of the DC series motor. Here you can see the graphical representation of speed versus armature current. So that means speed versus armature current means N versus IA. So we know the relation N proportional to EB by phi. For small load current, change in the back EMF EB is small. If the load current is changed, that means IA is changed, then back EMF is also small. If the load current is increased, then the back EMF is reduced and it may be neglected. Hence, for small current speed, inversely proportional to phi, as we know the flux is directly proportional to IA, the speed is inversely proportional to the IA. Therefore, when the armature current is very small, the speed becomes dangerously high. So that means the torque is minimum when the current is small, but the speed is dangerously high. That is why a series motor should never be started without some mechanical load. If the load is very much reduced, what will happen? The current is also reduced, and for that very reason the speed is dangerously high. Now the next slide is the DC series motor speed versus torque characteristics, or you can say the mechanical characteristics. Here you can see that this is a image or graphical image of mechanical characteristics. If torque is increased, then the speed is reduced. So this characteristics is also known as mechanical characteristics. From the above two characteristics of DC series motor, it can be found that when speed is high, torque is low, and vice versa. Okay, so this is inversely proportional characteristics. So these are the three characteristics of DC series motor. Now we can discuss about the characteristics of DC shunt motor. At first, the torque versus armature current. So what is the characteristics? We can see here the graph or graphical representation is straight. So if the armature current is increased, then the torque is also increased in a linearly way. In case of DC shunt motor, we can assume the field flux is mainly constant, phi is constant. Though a heavy load is phi decrease in a small amount due to increase of armature reaction, as we are neglecting the change in the flux phi. We can say that the torque is proportional to the armature current. Hence, the TA-IA characteristics for a DC shunt motor will be straight line through the origin. That means the flux is mainly constant here because the flux is dependent upon the ISH current. Okay, and ISH current is constant due to the RSH resistance is constant. So in case of shunt motor, the shunt field current is constant and hence the shunt field flux is also constant. So if the phi is constant, then the T proportional to Ia. So this curve is a straight line through the origin. Since heavy starting load needs heavy starting current, so shunt motor should never be started on a heavy load, because if the heavy load is attached with the shunt motor, it cannot be run or the torque cannot be generated because it is not a high starting torque motor, or the starting torque of the shunt motor is not high as compared to the DC series motor. Now the next slide is the speed versus armature current characteristics. So you can see here the speed versus armature current characteristics of the DC shunt motor. Actually, in normal case, it is if the armature current is increased, the speed is mainly constant. This is a constant speed motor. But if the load is fluctuate, if the load is increased, then the value of speed is slightly decreased in case of DC shunt motor. So as flux phi is assumed to be constant, we can see that N proportional to EB, and but as back EMF is also almost constant, the speed should remain constant, but practically phi as well as EB decrease with increase of load. As I have already told that if the load is increased slightly, then the armature current is, the speed is reduced. Okay, the speed decreases slightly, and generally the speed decreases only 5 to 15%. That means the speed decreases slightly if the load is increased. A shunt motor can be assumed as a constant speed motor. In speed versus armature current characteristics, the following figure, the straight horizontal line represent the ideal characteristics and the actual characteristics shown by the dotted line. Okay, so this is the characteristics of shunt motor. Now the mechanical characteristics of the shunt motor. So this is the speed torque characteristics. It is a constant speed motor. So if the torque is increased, then the speed is slightly reduced. Okay. For DC shunt motor, flux phi is practically constant. So N proportional to EB proportional to V minus IARA, that is also T proportional to IA. So here if the armature current is increased, that means if the load is increased, then the torque will be increases and EB decreases, so speed will be decreases, which is shown in the below graph. But the decreasing nature of the speed is very small, okay, as compared to the series motor. So this is the three types of characteristics of DC shunt motor. Now the characteristics of compound motor. So at first, compound motor can be classified into two categories. One is cumulative compound motor, another is differential compound motor, according to the polarity of the field coil. So cumulative compound motor are used where series characteristics are required but the load is likely to be removed completely. So if the load is very low or likely to be removed completely, but the characteristics is as like the series motor. So series winding takes care of the heavy load, whereas the shunt winding prevents the motor from running at dangerously high speed when the load is suddenly removed. Okay, so series motor means you have to start this motor with a bulk load, but if this is a cumulative compound motor, then you can start this motor as a series motor without the bulk load because of the shunt field winding. These motors have generally employed a flywheel where sudden and temporary loads are applied like in rolling mill. In case of rolling mill, the load is higher or sometimes it is very lower. So the compound DC cumulative compound motor are used in case of rolling mill. Now the next one is the differential compound motor. So differential compound motor means when the series flux or series field flux opposes the shunt field flux. And in case of cumulative compound motor, two fluxes are added. That means the series flux helps to aid the shunt flux. So since in differential field motor series flux opposes the shunt flux, the total flux decreases with the increase in load. If the load is increased, then the load current is increased. Okay, so flux is also increased. Due to this, the speed remains almost constant, or even it may increase slightly with the increase in load. If the load is increased, the torque is reduced, and if the torque is reduced, then the speed is increased. So differential compound motors are not commonly used, but they find limited application in experimental and research work. Okay, so this type of motor has no such practical application. Now the characteristics curve of compound motor. Here you can see the armature current and torque characteristics of compound motor, the series characteristics like a parabola, then the cumulative compound motor. In case of cumulative compound motor, there is series and shunt, each of these fields is present, and the series field and shunt fields flux are added with each other, so its nature like a series motor. But if the load is increased, then the torque is not such increased. That means if the load current is increased, then torque is not such increased as like the series motor. So its characteristics is lies between the series motor and shunt motor. Okay, now you can see the shunt motor characteristics also. And this is the shunt motor characteristics, straight line. Okay, this is the cumulative compound motor. It lies between the series characteristics and shunt characteristics because this is the combination of series motor and shunt motor, but the nature of this motor is like series. And this is the differential compound motor. If the armature current is increased, then the speed is increased. That means the torque is reduced. So this is like that. If the current is increased, the torque is not gradually increased. Okay, because the speed is increased in case of differential compound motor. And now this is the armature current and speed relation of various types of DC motor. At first, the differential compound motor, as we have already discussed, that if the armature current is increased, that means if the load is increased, then the speed is also increased in differential compound motor. So if the current is increased, then the speed is increased in case of differential compound motor. And this is the shunt motor. It is practically constant speed motor, but if the load is increased, it is slightly reduced. The speed is slightly reduced. And the cumulative compound motor, which is lies between the series and shunt motor. So if the load is increased or load current is increased, the speed is also reduced in case of cumulative compound motor. And now the series motor. In the series motor, we know that if the current is increased, the speed is gradually reduced. So this is the series motor characteristics, and these all are in full load condition. Okay, in both of case these are in full load condition. So that's all about the characteristics of DC motor. Thank you.